Shivkumar? Shivkumar?
Hello.
Yes, Shivkumar, are you there?
Yes, sir. Yes.
Okay.
Sir, please start.
Yes.
Shivkumar,
Shall I
sir,
start?
please.
Shivkumar, you can start.
Yes.
Sir, we are starting the webinar right now. Okay. Thank you, sir.
A good discussion increases the dimensions of everyone who takes part. Randolph Burney, a progressive writer, once said, "We are all gathered here today to have such a wonderful discussion through a technical webinar on role of artificial intelligence and machine learning in aerospace." This webinar is organized by the Institution of Engineers, Coimbatore Local Center, in association with the Department of Aeronautical Engineering, Sri Ramakrishna Engineering College, Coimbatore. So, to begin the session, I invite Dr. J. Krishnamurthy sir, IEI Coimbatore Local Center Chairman, to present the welcome address.
Thank you.
Sir, yeah.
Yeah, very good morning to one and all present online for this IEI technical webinar on role of artificial intelligence and machine learning in aerospace, being organized by IEI Coimbatore Local Center in association with Sri Ramakrishna Engineering College under the aegis of Aerospace Engineering Divisional Board of IEA. The Institution of Engineers India is a prestigious professional body with over 2 lakh engineers from various disciplines as members. It is headquartered in Kolkata, having 125 centers across India and 6 overseas. Our Coimbatore local center has been active for the past 60 years. IEI supports a wide range of technical activities, including guest lectures, workshops, seminars, webinars, exhibitions, international and national conferences. It also sponsors students' events such as quiz programs, paper presentations, technical competitions, symposiums, and project exhibitions. Additionally, it also provides funding for final year students of diploma, undergraduate, postgraduate students, and PhD scholars. As chairman of IIA Coimbatore Local Center, I am delighted to deliver the welcome address for this webinar. I welcome Dr. P.V. Venkatakrishnan, Chairman IIA Aerospace Engineering Divisional Board, to this webinar. I would also like to extend a heartfelt welcome to our distinguished panelist, Dr. Shantakumar Mohan from IIT Palakkad, Dr. G. Basant Kumar from Jain Deemed University, Bangalore, and Dr. K. Ramesh Kumar from Garuda Aerospace Private Limited, Chennai, who will be sharing their expertise on the applications of AI and ML in the aerospace sector. I also wish to welcome Dr. P. Chandramohan, Professor and Head, Department of Aeronautical Engineering, Sri Ramakrishna Engineering College, Coimbatore, who will be moderating this event. I would like to express my sincere gratitude to the principal and management of Sri Ramakrishna Engineering College for their continued support and collaboration with the IEI Local Center in organizing various technical events across different engineering divisions. Additionally, I would like to welcome Dr. G. Madan Mohan, Honorary Secretary of IEI Coimbatore, Mr. R. Sivakumar, faculty member in SREC, and Mr. Ayan Dev from the IEA headquarters technical department, whose contributions have been instrumental in organizing this webinar. I am pleased to also welcome IEI council members, various committee members, IEI corporate members, faculty, staff, and students from Sri Ramakrishna Engineering College, as well as participants from various sectors across the country. I hope this seminar will serve a valuable platform for knowledge exchange, fostering a deepest understanding on the role of artificial intelligence and machine learning in aerospace applications. To all the participants, I wish you a rewarding, insightful, and experiencing a good experience in this seminar. On behalf of IEA Coimbatore Local Center, I welcome you all once again. Thank you.
Yes, sir. Thank you very much, sir. Now I call upon Dr. P. Chandramohan sir, Professor and Head Department of Aeronautical Engineering, Sri Ramakrishna Engineering College, who is going to be the moderator for this particular technical webinar, to describe about this webinar and the panelist. Sir, kindly take over the session.
Thank you so much. Very good morning, one and all present in this webinar. Really thankful on behalf of our management, Sri Ramakrishna Engineering College, our principal, Department of Aeronautical Engineering, and my own behalf. I thank Institute of Engineers for giving me this opportunity to be the moderator for this wonderful morning webinar. On this webinar is about 3 sessions. We are going to have 3 sessions. Each session is going to be for about half an hour, 30 minutes. The first session is by Dr. Shantakumar Mohan, Professor, Department of Mechanical Engineering from IIT Palakkad. The topic is on introduction and discussion on artificial intelligence and machine learning in aerospace applications. So, followed by this session, Dr. G. Vasant Kumar is going to, G. Vasant Kumar, Assistant Professor from the Department of Aerospace Engineering, Jain Deemed University, Bengaluru, is going to present on introduction and discussion on AI and ML in aerospace research and development. Followed by the third session by Dr. K. Ramesh Kumar, Senior Instructor, Garuda Aerospace Private Limited, Chennai. The topic is on introduction and discussion on AI and ML in UAVs. So these 3 sessions are going to be for each 30 minutes, followed by discussion session. So the participants, if you have any clarifications, you can post it in the chat, and I can get the information from the resource persons, and we can have discussion at the end of all these 3 sessions. Thank you.
Thank you, sir. Thank you for the introduction about the panelists and the topics. Now, without delay, we can start the session. The first session will be handled by Dr. Shantakumar Mohan, sir, on the title of AI and ML in aerospace applications. Dr. Shantakumar, sir, is working as a professor in the Department of Mechanical Engineering, IIT Palakkad. He has published more than 100 research papers in the referred journals, and he has received Outstanding Young Scientist Award in the year of 2014 from Korea's Robotics Society, and he is having the Fellowship of European Master on Advanced Robotics Plus and Alexander Humboldt Fellowship. Now I'll hand over the session to Dr. Shantakumar Mohan, sir, to discuss about on the topics.
Thank you. So let's start sharing the screen. I hope you are able to see my screen.
Yes, sir.
Yes.
So first of all, welcome to this webinar, and thank you for the organizer to invite me to deliver this talk. So this is a very small, brief session, as already the panelist and moderate said. So I'll try to put a set a tone, or even probably a tone related to AI and ML application in aerospace. Although I am basically from mechanical engineer, so I used to work on aerial vehicles and as well as aerial robots. So probably with that expertise, I can talk about this AI ML application in aerospace. So before going to talk this, so I just give a brief about our institute. So IIT Palakkad is just a 10-year-old institute and 1,300 students. So IITs are actually like a premier institute in India. So we are 3rd generation IIT. So we are located at Palakkad, which is very close to Coimbatore, around 530 acres campus. So we have moved to our permanent campus 2 years back, and all the research infrastructures are available. So I just mentioned one point because this is very relevant to this particular context of this talk. So we have a motion capturing equipment which has a 12 camera and high quality, you can say, sensing thing. So which most of the aerial robot people uses. So you can actually like try to reach us, and you can also avail the facility whenever you require. So this is the point I just want to make it. So I hope now you are clear. So I'll just move it. As I already told, I am basically a mechanical engineer. I work in robotics and control in a broad spectrum. And I worked for my PhD dissertation in field robots, specifically in underwater vehicle. Then I moved to you can a short period, almost like 2 semesters in NIT Calicut, and then I moved to Korea. So KAIST, which we call Korean Advanced Institute of Science and Technology, where I worked more rigorous area of field and service robots. Specifically, this would be helpful for even an aerial robot because the sensor fusion, integration, and as well as observer design are very, very critical for any field robot, whether it's the aerial or underwater or even a ground-based system. So this is the area I worked. In fact, the collaborator or the host who did, you can say in KAIS, he was an aerospace engineer in Stanford and his PhD and MS in aerospace. And then he worked in 10 years in a, you call Optimal Synthesis, the company. So this is very close to a aerial and aerospace industry. So that exposure gave lots of idea for me. Then I joined IIT Indore initially in 2012. Then I moved to IIT Palakkad. But the very first problem statement which I address in IIT Indore is a aerial robot, specifically on a, you can say, land-based navigation system. That too you call some called sensorless navigation system. That is the way we started working. And then I exposed my lab into a bigger center called Center for Robotics and Control, where lots of focus which we made. So that is the area which I worked, and slowly I moved to other leg also, the medical assistive device and parallel robots. So this parallel robot also would be helpful for aerial robot, specifically for, you can say, stabilization of image or stabilization of camera, even stabilization of your simulators. So where the parallel manipulator definitely will work. Even I have a small, you can say, funny thing. I think some of you might have seen the movie called Lift. So in that movie, they have to actually like break the bigger you call wallet. So for breaking this wallet, they have to actually like use a laser gun, and then that's supposed to be stabilized. So this robber, who was the you call commander, so he would be asking one of the scientists who is working behind, or probably the engineer who worked behind for this wallet breaking. So this way I asked, so I could not stabilize this particular laser gun. That's why I'm actually like nervous. Then this robber who's the captain, he said that, hey, why can't you use a Stuart platform? This is the application which the parallel manipulator would be known. In fact, in that movie, this was mentioned. So I was very happy that so people are aware that Stuart platform and parallel manipulators are good in stabilization. So that is the overview of my background. And I have a lab which is we call Safe Robots Lab. So we work on service assistive field and exploration robot. So few of the robots I shown, because we are not working on only conventional robot. We work a little, you can say, non-conventional. So few of the robots you can see, like this is a big kind of model where this can be considered as a wheel and you can say leg kind of thing. So and you can see this is also like leg the beak, and this particular robot is actually like little interesting because you can see already we have enabled the AI based autonomous you can say capability. So now this robot supposed to, you can say, give us surveillance for the armed people. So a small test we have done in our you can say campus. This is a small terrain which is located in our you can say campus. This is supposed to go over here and then small, you can say, inspection and has to come down. So that is the idea. So you can see like this is actually like navigating the obstacle and going up and down and then comfortably coming. So that is what the area. So you can see here this robot is actually stack climbing, and as well as it can go on all terrain. In fact, the same robot when I was in Germany, we establish even it can walk through the surface of the water. So it can actually like work in a muddy or you can say surface and solid surfaces. So this can actually like work. This is we named when I was in Germany. We call this is Asgard 1 to 4 versions we have developed. That is the idea. So now we go back. So as I already told, I am expert in underwater robots. So we do work on underwater robots also. So I put two of the interesting prototype, which was recently commercialized, and some of the products would be available probably end of this March. You can see. So one is actually purely observation, that too like a very silent, like a fish robot. So the other one is actually like for a harbor or probably a ship building industry, or even in a you can say surveillance and reconnaissance industry we can actually like use. So this is actually like intervention class where there is a manipulator on top of the vehicle. This is a purely observation. So the same direction. So we worked even for a defense application where the ammunition handling. The ammunition handling was the you can say very closed area in our say group. But before actually like commercializing that aspect through ML, we thought of actually like showing the capability in other area. So we actually like make it, you can say larger fruit or vegetable harvesting area. We have actually like put this particular application and we have communicated towards. So this is the area where I work, and I'm actually like strong believer of products. So in my group, whether they are internship student or a BTech or PhD student, they always have a product design or product at the end. So they will be working. These are few of our BTech projects in the last 12 or 13 years in my IIT life. So you can see like this is one of the recently developed aerial come, you can say line following robot. So there is a cable line, high tension cable line. So that inspection can be like done with the small we call cable laying robot. So this is one which we have developed, and this is another robot which is actually like convertible. So you can closely look at, there is a rotor also inbuilt. So this is a belt driven. So this very similar to a Marv which you would have seen in a you can say LinkedIn or YouTube. So this robot will actually like convert into a wheeled or you can say aerial robot. This kind of robot system we work. Now coming back to the original topic, which is introduction to AI and ML in aerospace engineering applications. So before going to talk that, so far whatever I presented is purely based on my research. So the next few slides I will be running through, you can say what I expose and inspire. So I don't want to cite then and there. That's why I'm putting this disclaimer. This is the regular practice I used to put it in my NPTEL lecture, so I put it the same way. It's purely for educational purpose. So I don't want to write everything then and there. So when you talk about aerospace, I hope you know aerospace is a bigger area. So it is having a aeronautical and astronautical. So I'll be focusing the application towards you can say aeronautical. So although we call aerospace, I will be focusing on aviation industry. That is the idea I just put. So that's why this particular picture also will say it's a aviation industry. So when you talk about you can say AI and ML application in aerospace, so before that, you just recall. So most of you know like what is AI and ML, but just to recall, so AI and ML are actually like very simple in definition. So you can say imitating the, you can say human or probably animal brain. So that is what we call, you can say the human intelligence that you imitate in artificially. This is what we call artificial intelligence, directly stimulating or simulating the system based on the human intelligence. So when we do this, there are several, you can say algorithm and logic and methodology we have to use. One of the bigger algorithm set we call machine learning. So this actually like enable computer to learn from the data and make decisions. So now, so when I say AI is actually like a broad one. Inside ML is there, but since the topic was AI and ML, so I just put it the definition. Okay. So now coming back where we actually like end up. So we said that the aerospace industry, what we are bothering, that to aviation industry. So the AI application in aviation is multifold. So every point you can actually see, even from you can say you call airport management to even a ticket management to passenger safety to a further feedback collection. Everywhere you can actually like put AI application in the modern days. So in that sense, you can see that the safety risk management to even revenue management, everywhere the AI can be applied. So what the broad spectrum is actually like very close. Since I am mechanical engineer, so I thought so few topic which can be actually like one of the interesting since it is in a aerospace engineering students and the community. So the bigger part is actually like following or probably lying in a traffic management, flight operations, and maintenance. If you talk about aviation to even aerospace in a bigger picture, so then the AI application is very, very broad. So before talking that, so when you talk about AI, so AI is having a twofold. One is analytical AI, the other one is actually like operational AI. So the analytical AI is actually like based on your experience, based on the repetition, based on the redundancy. So you can actually generate. For example, when you use probably you call Amazon, you call just app. So when you are actually like searching, so today you are searching that okay, so the you can say slim trousers. So you search. So then what happened next time when you come, so then it will give the before you are actually searching, so this is where you left and this is what interesting towards you. So this is what we call analytical AI, where based on your data and experience, so the solution would be provided to a betterment. But that would be actually like one fold in aviation and aerospace industry would be done. And this is very, very matured. It is purely based on the data and based on how you repeating the activity. But the other AI, which we call operational AI, this is still getting matured. So this is very, very close to the real world or physical world. So where you are actually like trying to bring a new kind of concept. For example, so autonomous aircraft. So autonomous aircraft is not just like you call analytical AI. This is actually like purely an operational entity. So that part, when you talk about operational AI, so that is having a huge application because it is still getting matured and lots of scope for the young buds like you can say students and as well as the potential researcher like academicians. And you can actually like see that the analytical AI has a ready-made packages which you can actually like easily implement, whereas the operational AI you need some expertise to explore and then implementation. So that part you can actually like take it little focus. So in that focus, if you look at it, how AI could impact the aviation industry. As I already mentioned, I am putting aeronautical is the focus. So in that sense, you can see that the smart maintenance. So in fact, we want ease of maintenance or no maintenance, but that cannot be done. So in that sense, we are actually thinking about a smart maintenance. So when you talk about smart maintenance, it would be definitely a predictive and preventive maintenance. So that is where we are bringing when you put AI into a picture of aviation industry, so then definitely you can save energy. So here the energy in terms of you can say fuel efficiency. And the other part, so several times you would have seen that when the training happened, the aircraft crashed. So severity and fatality can happen. So that can be avoided using AI-based training simulators. So this is actually like one of the bigger aspect because when you take aircraft, even a jet for our flying or fighter jet. So the fighter jet is a multiple crews, and when you launch every time, huge money involved. But the same experience, if we are trying to bring it very close to the real exposure and experience through the help of AI, that would be a major change. That is a bigger application in most of the well-developed countries already implementing. So the even the driving license for a truck and a bus and all in a modern countries they use AI simulators, right? The same way AI simulator can be used for practicing engineers and practicing pilots can be used. So that is where we can actually like put it. And the next part is one of the interesting. So because when you talk about, you can say aviation or aerospace, so one of the bigger problem is actually like the design. So you need to actually like improve the design day by day, and you have to actually like improve the performance in, you can say better every stages. So in that sense, the generative design or probably the innovative product design is one of the critical part. So there, if we apply AI, so you know what you have done in the previous and what was happened from previous to this. So the changes would be recorded and data would be available. So based on that, what you expect that can be easily generated. So that's what we call it a generative design. We'll see in a better, you can say in detail in the upcoming slide. The same way, if you look at it, the customer service and as well as their satisfaction can be achieved better if we apply AI. So that is the whole idea. As I already said, the generative design, right? So you can see the AI-driven design innovations will give lots of, you can say, interesting idea. And the interesting idea would be optimized if we apply the technology and algorithm properly. So which will give very interesting aspect in terms of, you can say, the modernization of the design. For example, you talk about Airbus, the old Airbus 310 or 320 to, you can say, the modern Neo. You can see that the blade at the end, you can see the curved has come. Earlier, it was actually like just a fixed pin would be connected, but now it is actually like in a wing itself, it is actually like curved bend. So this is what we call the, you can say, improved design. So now you know this curved one is actually like better design in terms of mechanical engineering aspect. So now when you are actually like moving towards, so the previous one is fixed fin which is attached on the wing. So now it is actually like integral part of the wing which is a curved, you can say, fin. So now you can actually see that the improvement happened. So now the AI will say that what would be the future based on the optimized design as per the, you can say, parameter which you set. So that make, you can say, the design options are multiple. If the design options are multiple, then what happened? You can actually like employ even the AI based 3D printing and other technology. You can actually like even prototype faster and verify better, and this will enhance definitely the efficiency and the fuel economic things. So that aspect, if you look at it, so you can see this picture. So the normal paper become a jet, right? The same way, the next picture you can see like every part was actually like the data would be put it in a cloud, and then you are trying to take it and improve it. So in that sense, you can see like the parts would be very robust, and whenever you are making a part, that would be ergonomically, economically satisfied. And based on this, you can actually like see that you can make it dynamic designs, and then it can actually enhance whatever component you are bringing. The same aspect, if you look at it, so several times the pilot, most of their working time is actually like planning their path, planning their, you can say, the, you can say, end to end thing. So they will see the forecast and they will actually like get the communication from air traffic control, and then they plan tentatively how to fly. And then later on, so based on the, you can say, real time environment, then they will actually like change their, you can say, course of actions. Everything will be actually like coming. So in that aspect, if you actually like put it a based thing, so even from the pushback to a landing, so some tentative designs or probably tentative course of action would be putting towards to the pilot. Now the pilot can actually like validate this is actually like good or not, then he can actually like make it. In that sense, even a climbing trajectory or where you can actually like cruise, everything would be given. So based on the pilot experience, he can actually like enhance this, or probably he can adapt this, and then he can actually like go again. So if we adapt this way, so lots of benefits will come. Even the autopilot will be enhanced by the AI. That is where we can actually like see the better fuel efficiency can be achieved. The same way, if you look at it, lots of time the aviation industry is actually struggle in a, you can say, supplies. But if we adopt the AI-based supply chain management, the supply chain management will be effective and economic, and as well as actually like faster. So that is where we are actually like looking at. So for example, you see from demand forecasting to even final relationship management, everything would be monitored and controlled by the AI base. So in that sense, several of them can be automated. So that definitely boosts the efficiency in, you can say, inventory. So even you no need to talk about inventory, even the repairing or supply chain would be completely as well. As I already said, the preventive maintenance and predictive maintenance would be there. So now that would be streamlined with, you can say, your supply chain. Hey, my aircraft is this particular aircraft required. These are the components in this particular month. So you deliver. So before your aircraft is coming to the, you can say, the maintenance shop, so the components, everything would be arrived because you are already linked with the AI. That is where they are actually like bothering, and that is what the beneficial when you talk about. As I already mentioned, the training and practices are actually like cheaper if we think about AI-based simulations. So even this would be helpful in other aspect, for example, in-flight assistant. So sometime actually like the some of the critical situation you might have not entertained during your regular, you can say, experience and as well as regular training session. But if AI enabled, so even it can actually like provide the in-flight assistance. So these all actually like a very good package when you implement AI and ML in a aviation industry. That is where they are thinking about. And several times you would have seen, even I am actually like from Kerala now, right? So several times if I want to land in Kochi, so the pilot would always say that we are not having a clear visibility. So we are actually like redirecting the flight for some more time. We will come back and try. Otherwise, we will land it in Bangalore or probably Coimbatore or Trivandrum. The funniest thing is we might have started in Bangalore and we may be heading back to Bangalore and for landing. This is really funny, right? But if we know the weather condition prior, we can plan when to land and where to land, or even the visibility is the only problem because of the smog or some other, you can say, unknown problem, then we can actually like make different imaging techniques. So then we can actually like make the pilot visibility is better. So that is where the bigger problem. For example, Delhi airport. So the visibility is the only problem because of the several, you can say, planes would be cancelled or delayed, or it would be rerouted and the fuel would be unnecessarily wasted. But if the visibility is enhanced using the AI-based image processing, so that can be improved several things. That is what we are talking. As I already said, the better customer experience, right? So there are several fold. One situation you can think, so the planes all cancelled one particular time. So the passenger supposed to think about what to be done. So where is the next plane? So now, for example, the chatbot, which is actually like a personalized one for him. So now he search. So he no need to actually like search which airport is close by, where he can get the next plane, or probably his current plane was cancelled, or what is the next plane. All those options would be based on the cloud. It will be actually like generated and it will throw. So in that sense, the customer need not to actually like even worry. For example, even when he's actually like making a connecting plane, he landed and his, you can say, next plane was actually like already take off and he need to actually see what to be the next one. But before he is actually searching, when he open his mobile phone with his personalized, you can say, the app, so it says that okay, your plane is actually like due to your incoming plane, it is actually like missed, but you have another connecting plane which is already airline is seeked and you can use this. So in that sense, the customer would be, you feel completely a pleasure and no tension at all anytime. So these all can happen. So that where we are actually like doing it. And you know already AirSeva and all those, you can say, airport security check, everything is already started enabling. For example, image based security check-in and airport entry, everything is started happening, right? So these all actually like make it very efficient in terms of, you can say, moving into the airport and aviation industry. So this is where we are actually like more. The same way, if you look at it, one of the bigger problem in aviation industry is traffic management. the ATC tower would be struggling to communicate to individual plane and how to make plan of each one landing, right? So in that sense, if I think AI enabled, so the route would be optimized and the conflict will be completely avoided, and lots of automation will improve efficiency. For example, the human would be struggle, but AI will give supplement. Okay, this is what the option for this plane and this is for this option. So then you can actually click, once you click this option, so the next option for the next plane would be automatically readjusted. So the conflict and you can say stress will not be there. So in that sense, AI will give the safer route and the runway would be properly management. As I already said, the visibility scenario also would be taken by the AI aids. That is where we are actually like moving. So in that sense, one of the bigger problem, not only traffic in airport. So the runway inspection, every then and there, the runway need to be inspected. And is there any problem and every other issue? So in that sense, AI can be used along with other upgraded sensors and computer vision technology. Even any debris or any foreign objects are there that can be identified and removed, and safety would be ensured, and the runway would be cleared. And is there any crack or pothole, everything would be intimated, and we can reroute it according to that without even physically you go. Even a drone based inspection or simple, you can say several pathway cameras are actually like enable and inspect. That is where the runway inspection can be. One more threat also can be avoided. The threat detection and identification can be done based on AI. Based on that, passenger can be secure, and it is actually like civil or commercial, everything can be enabled. So this is already few of the you can say developed countries started using. For example, behind the airport, if anybody is actually like intruding or not, easily we can check, and which passenger, what time, all those things can be recorded in the data, and then we can easily retrieve also when you feel some suspicious actions. And when the baggage has come, why it is actually like still rolling on the belt, everything can be actually like interrogated and checked easily if AI based techniques are adapted. So in that direction, if you look at it, so whatever I said are actually like in the aviation industry, specifically for aerospace and you call passenger or commercial aeroplanes. But the other side, if you see AI based, so the UAVs and drones are actually like maturing. And when it is actually like maturing, so you need advanced technologies. The advanced technology is actually like AI enabled. This would be much faster and much beneficial. There are some, you can say, setbacks and limitations that we would be seeing. But if these all enable, the UAVs world are actually like very, very, you can say, dream kind of thing. So that is where we are actually like focusing. Even you would have seen in the war field, the drone attacks, or probably in agriculture, the drone based, you can say, inspection, and as well as you call even monitoring and other things are happening. Even spraying, harvesting, everything started happening, right? So in that aspect, the AI is actually like enabled in two broad fold. So one is navigation side. So the other one, even the system operation side. So both side, the AI is actually like enabled, and we are actually like happy. So AI is supporting. So when we see that AI is actually like in navigation and aerial vehicles, so then what really is the bigger problem? The driven safety enhancements, right? The what kind of safety you are actually like trying to make it. So autonomous decision making is available for the system, and real-time monitoring is enabled. So these two are there. On top of that, the add-on is preventive maintenance also enabled. So the MI models will actually forecast when the system will fail, and when you have to replace, when you have to give for maintenance, how long the system will fly, how long it will be work. All those things would be, you can say, then and there you can actually like monitor and you can inspect and then even replace. So that is the whole idea which we are focusing in that direction. If you look at it, so the benefits of AI in aviation industry is greater safety, improved efficiency, and the cost is definitely drastically reduced. But what really we are looking in the future? So autonomous flight, this is very, very bigger picture, and intelligent air traffic management. So AI-based robot enabling traffic management. This is what we are actually like seeing. Although the preventive maintenance start coming with the ML, but what we are looking at advanced preventive maintenance, even repairing. So that is what we are actually looking at. In that direction, you can see that the safety and the risk management would be enhanced. So the airline operations would be very, very intelligent, and a personalized passenger experience can be made it. For example, you enter into a even the you can say the PlayStation in the airplane, or probably you can say that the entertainment system. So when you enter and you log your name, so based on your previous experience, so what kind of movies you will look at it, what kind of games you like it, everything would be personalized when you touch it. This is what we call Industry 5.0, right? The personalization that can happen even in the aircraft or when you are ticket booking. So you are always booked in a window side, that too in a front seat with the Excel seat. So every time when you are actually like logging in, so immediately it will give that preference, which plane this is available, all those things. So this kind of personalized passenger service would be enabled. So that is where the experience would be very dramatically improved. So based on that, you can see that all the security measures and human AI enabling also will happen. For example, when the robot has come, people think that it's a wild animal, but now we are not seeing robot as a wild animal, right? So that way, when you think about AI, and that too like in aerospace industry, so you should be actually like very, very collaborative in nature, right? Otherwise, you will not be trusted. So that collaboration will definitely will come. The bigger problem is the ethical and regulatory norms. So that also will improve and then will come into aviation industry, which will take it to a sustainable operations. When you talk about this, I already said there are several risks. Since we are actually talking about AI, so definitely cybersecurity is a bigger problem, and reliability of the system when it fail, when it is not fail, that should be ensured. For example, any aircraft you take it, the flight control, you want to test it. So the first thing the tester or the inspector or the you call the authority will ask, is there any fixed gain controller enabled in your flight craft or aircraft? If that is not there as a stand backup plan, so they will not even approve your, you can say, flight control system. Anytime the backup should be a constant fixed control gain based control scheme. The same aspect will come, the safety and reliability part. So that is the bigger aspect. And there's supposed to be a transparency. If I use AI several times, the you can see the ability and the transparency may be missing. As I already told, the ethical and legal is the bigger problem, and data quality sometimes may be poor, that need to be improved, and sometimes even the data would be not available. How we will overcome that? So sometimes the cybersecurity is one part, but the other one is even cybersecurity is not there, some unintended consequences. So for example, I asked the aircraft to rotate positive 30 degree, some unintentional, so it probably it is minus 30. So it would be definitely a risk, right? So that kind of problem can come. So that is where the risk. So that aspect, if you look at it, the interaction and the dependency, how far you can actually like relate. And the last one is one of the important thing, the certification clearance and the challenges for the regulatory. That is where we are seeing. So as I already told, we are looking on the operational AI aspect, that is act on data to perform real world actions and manage the physical system or it connect to the physical world. Whereas analytical AI is very simple, but the operational AI is what we are trying it. That's why even autonomous car or autonomous aircraft is still evolving, whereas you can say some kind of recommendation or machine failure, fraud detections, all are already available to you. That is the idea. So when you see this operational AI, there are multiple. I stop at this point because it's already 30 minutes. So as the talk is very brief, I could not go anything in detail. So my expertise in aerial robots, so I did not go that deeper in a UAV or drones. So I close this session
No,
for the next speaker.
noted, Professor. Thank you so much. Thank you so much for your wonderful presentation.
So any of the questions and answers are at the end. So I'll
Yes, yes, Professor. At the end, we will have a look at the questions.
sure.
Thank you so much at this moment. And Shivkumar, can we
Yes,
invite
sir.
the next person, please?
Yes, sir.
Yeah.
Thank you, Dr. Santakumar, sir. Your session was really very much resourceful, and the topics were really more wider in the research perspective. Now I call Dr. G. Vasant Kumar, sir, Assistant Professor from Jain Deemed University, Bangalore, for handling the session on AI and ML in aerospace research and development. Dr. Vasant Kumar, sir, is basically an aeronautical engineer, and he done his PhD at IIT Madras. He was working with the Reseda Aerospace Group as a test engineer and assistant professor from Amrita Viswa Vidyapitham, Coimbatore. And now currently he is working as assistant professor in the Jain Deemed University. Sir, kindly take over the session.
Okay, thank you, Dr. Shivkumar sir, for your introduction. Is my screen visible?
Yes, sir. Yes, sir. It is visible.
Okay. So the topic that is given is artificial intelligence and machine learning in aerospace research and development. I'm basically fluid mechanics person. My area of research is in experimental and computational fluid mechanics. During the course of my work, what I found was AI can be used, especially ML can be used for the research purpose. So for that, I started working on this. So I will give the brief overview of what actually, so this is the way I have structured the talk. Since this is a very general introduction, I want to have, a clarity between what is an AI, what is an ML, what it can do, what it cannot do, where you can apply those concepts when you are doing a research. AI is not just something like a magic wand where it changes everything. So there are some limitations. For that, you should understand what AI means, what ML means, and where we can apply. I have taken only 3 examples. It's all very basic level. Further, we can actually discuss where we can apply these concepts in real life. Okay, I'll start with AI. You can see that people who have been using the phones or any kind of day-to-day activities, we are actually seeing tremendous changes that are happening. One thing that I was able to link is the availability of data. Of course, there are a lot of other reasons, like computational power has improved, and the way we have a very resource is limited and population is growing, so there is a necessity. But there is a saying that if you don't have a wall, you cannot draw. So that wall is the data. So how much is the data that is generated? You can see that in 2024, it is 147 zettabyte. So it is 1 into 10 power 12 GB of data that is there in the worldwide. I don't know who has calculated this data, but it gives a very basic idea of how much data we are actually consuming every day. So this is the core of AI and ML. Okay, so with that, let's go to the what is the difference between artificial intelligence? What is artificial intelligence? What is ML? Artificial intelligence is simulation of human intelligence. It is just you can think of artificial intelligence as something like as a person, you are making a decision. Okay, today I'm going to go there. Today I'm going. So this kind of decisions you don't even take time to think. So it automatically happens like that. You don't need to program something. It automatically happens. That is artificial intelligence. Machine learning is one of the ways to achieve the artificial intelligence. Okay, so this is machine learning. There are different tools that can achieve artificial intelligence, and machine learning is one such tool. Okay, so this is the way. It's a common diagram. Sorry for the other language. I wanted to have free open source drawings in the presentation. So this is AI, ML, and DL. So AI is overall it's a wider kind of thing, and ML is a subset, and DL, deep learning, is the subset in the ML. Okay, so this is the way it goes. Let's go into some examples, then I will be able to explain it better. So we have three different types of AI. One is a narrow AI, like that we are using Siri, Google Assistant, and self-driving cars. They are all like beach horses. They are programmed to do one thing, and they do it very well. For our aerospace application also, narrow AI is sufficient because we have to have one particular task given to a system. So that is narrow AI. Generative AI is what we are seeing as a ChatGPT. They are much more like you can ask it to have a text kind of input and a video input, and you can ask any kind of questions. It will be able to answer. It will be able to solve. So multiple tasks it is able to understand and give you response. That is generative AI. And general AI is whenever people think of artificial intelligence, they think as general AI, like a robot, like what we saw in the movie iRobots or something, a robot which is able to think, make decision on its own. With the current technology, general AI will take much more longer time, and many different kind of like the amount of data that we have generated, even though it is humongous, but still for general AI, it is much more complex. So it will take a long time for us to reach the general AI level. For now, we have reached up to generative AI, where like ChatGPT, Bard, and all are examples. Okay. Coming to the next part. And the machine learning, now we can differentiate between machine learning and artificial intelligence. Artificial intelligence, I am giving you an example, like building a robot, it is artificial intelligence. A robot which actually does everything, or a car, self-driving car, is an artificial intelligence. For a car to go on the road, it has to have visually, it should be able to see one object and identify whether it is an object or a car, something like that. For it to identify that, we need machine learning. So that is the difference between artificial intelligence is as a whole system, machine learning one component. The subtask that is there for an artificial intelligence to be complete, we need a machine learning. Yeah. Yes, someone asked something. Okay, so machine learning, there are different types of machine learning techniques. It's called supervised, unsupervised, and reinforced machine learning. In supervised machine learning, your data should be very clear cut. There is a input and there is an output. So that is a supervised machine learning. Reinforced machine learning, it is partially semi-supervised, you can call. And unsupervised machine learning, we will see some of the examples when we go into the actual application part. Where this neural network fits in, this is just a basic introduction. You can go deeper into the neural networks. So machine learning, here you can see that there is a regression, a classification. They are all called a supervised machine learning. But how do we achieve these machine learning techniques? Through neural networks. You have, let's say, I want to have, like when you are looking at an object, you can say that, okay, this is a car. This is a car made by this company. So you are actually looking at an object, or you're able to identify what actually is that object. That is the way our brain works. Okay, neural network is something similar. It's not like a human brain, but something similar. The way people have understood neural network, they have tried to model that. There is some input layer, and this is all hidden layers, and there is an activation zone or output layer. So what happens is that you give an input, and through the input, there are something called as weight functions. So all these arrows that you are seeing from so this is an input, and there is something called weight functions, and this is going to the second layer, third layer. So when you finally get an output, you should know that, let's say, example is that I have a shape. I have a circular shape, or a triangular shape, or rectangular shape. So what we have seen here is that input layer is given like a circular shape, and when it comes as an output and it is not a circle, there is an error. So that error is computed. So this is just a probability here in the output layer. You will be seeing a probability of how much is the final answer correct. So you should have one set of validated results at the output layer so that you compare and then give it as a input again to the input layer. So these weight functions will vary and the computations activation function will give a different kind of an output. So this is a basic idea of how a neural network works. And this neural network is applied to all this kind of supervised learning or unsupervised learning or reinforced learning. Okay. So there are different types of neural networks. I will just say one thing which we will see in our fluid mechanics application also. So convolution neural network is useful for identifying whether from the images and video, how to recognize, like if it is an image or a video, a normal neural network will not be able to work better. Like the forward feed-forward neural network is not that efficient. So we need a convolution neural network, and we have a different convolution layer, pudding layer, and activation function, which I mentioned earlier. So you have, let's say, an input which is an animal, and you have an output which is horse, zebra, and dog. So depending on, so you can see that the probability is 0.2, 0.7, 0.1. So this is the final probability. Initially, it would not be like this. So there is, the machine will be identifying it as an horse, or machine will be identifying it as a dog. So you have to find out what is the probability of that identification, and then give us a then error function will be generated, then give as an input to the hidden layer, then you will be able to fine tune your neural network. So this is an example of a convolutional neural network, which is useful for images and videos. And this is particularly useful for your fluid mechanics applications. Okay. So coming to our aerospace engineering, why do we need AI and ML? For the current this thing, you can see that there is going to be, everything is going to double in the short span of time, and for the 10 years to 20 years period. See, so you can clearly see, like during my time, we were not so frequently flying in aircrafts. So that was like considered as a luxury. Now people are almost thinking like, okay, what is a flight fare? We can check. So we have reached a stage where it is becoming much more affordable, and there is a requirement, and the societal and backgrounds have changed. So all these things have contributed to the improvement in our using the airspaces. So there is going to be a tremendous increase for the demand in aviation sector. Coming to India, we can see that there is going to be again a double in the requirement, and Boeing has already anticipating, like Boeing is anticipating more number of aircraft will be purchased by Indian Airlines. Okay, so there is clearly a requirement for AI and ML in aerospace engineering. Okay, 1 minute. Okay. So where we can apply this AI ML in aerospace R&D, we can go for the aerodynamics, fluid dynamics, and CFD, propulsion, predictive maintenance, unmanned air traffic management, structural health monitoring. So some of the areas that you can use the AI ML in aerospace R&D. I'll be talking about aerodynamics, fluid dynamics, CFD applications, and predictive maintenance. I will use one example of a digital twin to explain the concept of AI ML in predictive maintenance. And for the air traffic management, the drones are very common kind of now. Drones have become much more prevalent compared to what we have seen. So I'll take up unmanned air traffic management, one case where we will be discussing about the application of AI ML. Okay, so machine learning in aerodynamics and fluid dynamics, it is actually a tailor-made situation, we can say, for aerospace applications, especially for turbulent flows. We can see that turbulence is highly complex in the sense that there are, you can see in this figure, there are scales in the turbulence which cannot be resolved. There is no very closed form solution for solving turbulence equations. Okay, Navier-Stokes equations as such, but there are only turbulence models. Okay, so we are generating a lot of data through experimental observations, and we are using the different turbulent models. The turbulent models are called as RANs. Its very basic classification is RANs, URANs, hybrid RANs, LES, and DNS. RANs is the lowest level because it actually filters out all the scales, and then what we are getting is a averaged Navier-Stokes equation, and this is excellent for getting instant results, like for industrial application where you are not going to spend months doing the research. Then RANs is the excellent tool. It will give you fundamental input for your design aspects. So unsteady RANs is there. Then LES, actually turbulence is not completely isotropic or anisotropic. Okay, we are making an assumption in the RANs that it is isotropic. Okay, so that is not correct. In LES, what we have DNS is something which is in the pinnacle of computational simulations. Here we are going to solve the complete equation, but this is computationally very expensive, and even now very simple cases like a flow over a channel, flow past a simple sphere have been only carried out using a DNS. So there is a requirement for AI ML in turbulence modeling. So typical, so you can see that RANs equation, you have two equation models. This is a very clear example. Like this is a RANs modeling. You can see that everything is blurred out, and this is an LES. To a certain extent, we are able to see the scales, but in DNS, that is very clearly visible. And this LES also requires very small modeling, and DNS is computationally expensive. So here you are increasing the computational cost, but you are able to get a very good physics. What if we even without increasing the computational cost, you are able to have a converged solution and you are able to resolve the scales? That will be good, right? So that is where AI ML will come. So the research is in nascent phase, so we haven't completely applied AI and ML to turbulence research and got the final output, but we are in the nascent stage. I will discuss some of the works that is carried out. So this is one example where CFD RANs actually Spalart-Allmaras model in turbulence. You must have heard of this. People in aerospace start with the Spalart-Allmaras turbulence model. So what this paper that is done, CFD-net deep learning based method, you can refer to this paper. So what they have done is they have used the convolution neural network. So that we have discussed earlier, right? So there is a 6-layer neural network. So here in the example that I gave you, it was just 2 layers. It is 6-layer neural networks. There is an input and there is an output. Okay, so we have used the first few iterations. Physics-based solvers are used, and we are able to get the data, and then we are feeding it to the neural network. So this neural network will be able to compute the variables like pressure, temperature, velocity, etc. Even though, so the problem is, it is just the data. The main positive thing about artificial intelligence is that it doesn't worry about what kind of physics is there in that one. You just give a data, you train it, it will be able to give an output. So that is the beauty of that is the reason it has got application across industries. AML in aerospace or marine technologies, or what do you call ticketing software, as sir was saying, everything. So multiple applications are available for, because it just needs data. And then the problem comes where that physics is going wrong. If it is physics is not able, like you have you have to have a conservation of mass when you are solving a CFD problem. How that conservation of mass is what do you call it is verified at any stage, there is no answer. So in this paper, what they have done is output of CNN is given as input. There is an iterative refinement phase. In this phase, this conservation of mass, momentum, etc. is checked, verified whether it is correct. It is it's a conservation equations are being followed. Okay, there is something called as physics informed neural networks, SPIN. So you can read about this. Say there you will be so the physics component is also brought in instead of just the data. So this paper was able to give a very good convergence from 1.9 to 7 times faster than the CFD using and the OpenFOAM software was not able to. So OpenFOAM is a good software, but the convergence rate improved when you are using an AIML. So CNN, convolutional neural network. Okay. LES equations, I told you, LES equations actually, for the major part, like for the larger length scales, your mesh is sufficiently refined. So the mesh requirement for RANs and LES are different. For a RANs model, you want to have a refined mesh, but for LES, the refinement will be much more higher than a RANs model. So in this case, the smallest, this is called as filtered Navier-Stokes equation. Here you can see that subgrid SGS, it is called a subgrid scale model. Here we are modeling the turbulence. Okay, so this smallest subgrid scale model actually is coming from a model. Instead of RANs, we are modeling everything. Here only that smallest scales, that is with the high wave numbers, are modeled. What if we are able to use the AIML in the LES models? So machine learning, how it contributes is that it supplements the undissolved energy in the coarse mesh using supervised learning. We have studied in earlier, we saw that supervised learning is regression and classification. So supplementing that energy in the so through that regression and classification, you are giving the input, supplement the undissolved energy. And the second one is that unsupervised learning, developing agent-based approaches to stabilize the coarse simulation. So this core simulation actually is not able to resolve the scales. So you can see here that these smallest structures that you are seeing, they are called as scales. Okay, so from the largest scales, the energy is cascading to the smallest scale. So if you are able to use the machine learning and then give a supervised learning for the unresolved energy, that is the smallest length scale, you are going to give a supervised learning, then this approach is going to be what do you call, much more accurate compared to your simple LES model. Okay, but the problem is that for supervised learning, we saw that there has to be a data. Okay, let's say there is a data A and it will give an output B. So that high fidelity data is needed. Okay, and that will come only from DNS. DNS simulation was difficult in the first place. That is the reason we went for going for LES. Now, for LES to have a ML component, we need a high fidelity. I told you the probability, we have to test the probability with something which is benchmarked. So that data has to come. So initially, we have to have the data. There is no other go. The data set has to come from DNS. So that is the reason it is not completely implemented as of now. Like machine learning, now we can see Ansys and Fluent, it is not completely implemented. Over the period of time, when the data is available, these techniques will improve and it will get implemented. Okay, so my research, I just wanted to give one brief idea of what I'm doing. So here, what I am actually, here you can see that this is a NACA 4415 wing, and there is a laminar suppression bubble here, and there is a laminar flow here and a turbulent flow here. So what I was trying to find was how the flow will separate over the complete span of the wing. Okay, so for a two-dimensional case, the separation is somewhere at a point. Okay, you can see that shear stress going to 0 is the point where the flow will separate. But for three-dimensional cases, it is along a complete line. So I was able to get the equation for this line using oil flow visualization in case of a laminar suppression bubble. For a complete stall, this oil flow visualization will not work. So my aim is that if I generate more number of data, because this when curve fit is happening, there are some constants. So this constants is going to depend on the flow field variables. If I have more number of data, then what I aim to do is that when I have a wing which is placed in the wind tunnel with different angles of attack, different Reynolds number, I am able to generate the data, and then I give a generalized solution of how the laminar suppression bubble looks like for a cambered wing. Okay, NACA cambered wing. So that is the aim that I have started using the AI and ML. Okay, I will not go deeper into that. Okay, coming to the predictive maintenance part. Here, what we are seeing is that this I don't know whether you have heard of the term. It's called as digital twin. So there is actually a hardware system, and in the virtual world, the same in the 1 minute. The same system is generated as a virtual model. Okay, so here there are multiple sensors in the, let's say an aircraft will have different sensors. Okay, it's lakhs of sensors are there. All the data from the sensors are fed into a virtual digital twin. Okay, the problem here with the digital twin is that I will not go deeper into the mathematical part. It is just that some of the if you want to model a system, it is an n-dimensional system, and it is, if you want to solve a complete, let's say you are having an aircraft which is have a turbulent flow over it, you want to create a digital twin. It is very complex to model the complete aircraft exactly the way it is going to fly in aviation, in actual real life. Okay, so for that we are going to have some techniques to reduce that thing. So whether it is going to be reduced order modeling or sensor based and Internet of Things, we will take the help of that. So here, to sensor technology and Internet of Things, what it does is that I told you this is a high dimensional system which can be modeled as there is a reduced order modeling. Reduced order modeling is, you have a system which is having an n dimension. You are going to find out what is the most very influencing factor. Okay, so that factor will be identified and you will have a reduced order. This is the fundamental of an ML system. Let's say you are going to buy a house. So for buying a house, there are a lot of factors, like how far it is from this place, how far it is from the hospital, how far it is from the main road. There are multiple factors. So they are all the dimensions. But one thing will be like predominant for you. Either it is a monetary consideration, or it is location consideration, something like that. So this is I'm just giving a very crude understanding of a reduced order modeling, the way I understand. So you can refer standard textbooks on what reduced order modeling means. So what it does is that instead of taking a data from every sensor and then giving it to this thing, we will have a reduced order. The main sensor data is given, and then you are able to model the digital twin. Okay, so here this is a reduced order modeling. Here you have an n-dimensional system and you're having a reduced order. Okay, so this is an example where you are that way when you're projecting. So if you go deeper into the reduced order modeling, what you see is that when you are projecting the result, it will be similar to the n-dimensional result. It will not lose the data, like it will not lose the information. Okay, so that is a digital twin. Rolls-Royce has already introduced one engine, they have introduced an intelligent engine technology a few years back, where you have a complete digital twin of the actual engine, and the data that is fed into the engine through the flight, it is given to this. Okay, so what it does is that before it is going to fail, the virtual engine will indicate, because you can model this virtual engine when it is going to fail, how it is going to fail. So instead of actually waiting for the actual aircraft engines to have a malfunction, then you find out what is the reason, then you do a case study. Here the virtual engine is exactly the real engine, but with the data coming from the real engine. Okay, so here you will be able to have a understanding of when the engine will fail. So this is a predictive maintenance example. Finally, I will wind up with unmanned aerial system, and you can see that it is for an unmanned aerial system, air traffic management at some point has to come into picture, because now the drones are not being used for the transportation to larger extent, but at some point it will come, and that point you should have a traffic monitoring system. And so AI can help in autonomous navigation, and there is something called a swarm intelligence, okay, and delivery of logistics, and this thing, and learning to fly. Like during the flight itself, if you are able to, like a bird actually is able to see a vehicle coming on the road and takes a diversion, something like that. So if you are able to model your system in such a way that it is learning on the fly, so these are all the things that you can give it for the drones as such. But majorly what I'm considering here is that the traffic management system. So one case study, you can take a look at it. There might be different cases. This is what I was able to find. Airways is one company that has created an unmanned traffic management system. It's a Israel company, Tel Aviv based company. It has deployed the AI. So the system has got anti-collision, dynamic management, temporary use space. So what it does is that if you want to fly a drone, you have to give the flight path and you have to tell from where it is going. So it will automatically get the inputs from the weather data, whether there are any other drones, and all these things it will get, and then it will be able to give the information directly to the drones whether that flight path is okay or not. Temporary use space is that if you want to have a flight, it's not like a fixed airspace, because in aircrafts you cannot, that whole thing is secretial, like we cannot you don't know what is a flight path. But in drones we haven't reached a place where we want to have a flight path as such. So temporary use space is created using this created by this company. If you want to take a flight, you can take a look at this their study and understand. So challenges in implementing aerospace system, we know that it requires high level of safety and reliability, and so one is that it as sir was saying, there has to be redundancy. Okay, if one system fails, the other system should take over. So whether it is worth spending so much of amount in AI, then you have a conventional system also, so that you have to think about whether in terms of cost, is it effective. And aerospace related data are generally classified. Mostly it is defense aircraft, fighter aircraft, data is classified. AI, even for this drag polar, you will not be able to get the data. Okay, so this data, if it is classified, how will you be able to train your AI model? Whether it is accessed by, if it is accessed by the whole world and researchers are working on it, then you will be able to generate results. Only that company is working on AI, then it will take long time. Cybersecurity challenges, someone can hack into the system and then they can modify the routes, or so that there are challenges in the cybersecurity area also. And people are generally they don't want change. Okay, so when you say that this is the system that is going to have take over there, so there will be definitely first reaction will be pilots and regulators. They will oppose to that changes, and there is a fear of job displacement also, because AI actually it doesn't get tired. So you can give any number of data, anything that you keep asking ChatGPT, like multiple questions, it keeps giving the answers. So that is one. So we have to mitigate all these challenges. Okay. Okay. Sorry. Where I was saying. Okay. Yes. Ethical considerations. It is considered a black box. Okay. So here we don't know what is going on in the AI. Okay. So there is a famous quote which I love, when statistics is, as a drunken man uses a lamp post, it is used only for support, not illumination. If you want to prove something, you take the data that is necessary for you, and then you say that this is correct, instead of illuminating the fact. So that kind of biases may come into the system, and it will be trained in that way. So that whole decision making will be different. Okay, so that we have to. And who is what is the regulatory authority? Who is responsible if something goes wrong in the AI? All these things, framework has to be laid out when you are going for an AI consideration. So as a summary, there are multiple areas where it can be implemented. We have covered 3 areas. One is CFD, in that RAN's LES model I have taken up, and predictive maintenance, digital twin, and unmanned aerials air traffic management system. One company has already implemented it, and you can take a look at it and see whether we can do a similar thing. So there are challenges and ethical considerations, but definitely there is going to be very just like our boundary layer theory was not that famous when it was introduced by Prandtl, and over the period of time it is something like that is going to happen with AI/ML, because the more I read about this thing, the more fascinating it looks. So in coming years, definitely AI/ML will be part of aerospace industry. Right. Thank you.
Thank you so much, Dr. Vasant Kumar. You had another wonderful presentation in a very short span of time. Thank you so much.
Thank you,
Mr.
sir. Dr. Vasantakumar, sir. Thank you for the broader and detailed presentation on the topic of AML application in the research and development. Thank you, sir.
Thank you so much.
The third session would be on the topic of AI and ML in UAVs. The session will be handled by Dr. K. Ramesh Kumar, sir. Dr. K. Ramesh Kumar, sir, is currently working as a senior instructor at Garuda Aerospace Private Limited, Chennai. In his career, he holded different roles as a mechanical engineer, senior mechanical engineer, research and development engineer in the different organizations like BEML and GTRE, Mechanical and Hydraulic Divisions, FMC Technologies, and UES Holdings Private Limited, Singapore. Now I request Dr. K. Ramesh Kumar, sir, to proceed with the presentation.
Okay, thank you, sir. So, good afternoon.
Good afternoon, sir.
So, is it visible, sir, my presentation?
Yes, sir, it is visible. You can proceed.
So, actually, now I'm going to deliver how this AI/ML, artificial intelligence and machine learning, it is used in unmanned aerial vehicles, that is majorly on the drones. Okay. So, these are all we are a Garuda Aerospace company. We are manufacturing agricultural drones in different classes, small, medium classes, and videography drones, surveillance drones, delivery drones. So we are having separate R&D divisions to develop the drones and data processing to provide the industrial services for various industries. So actually I am Ramesh Kumar, working as a head orbital establishment as well as the senior instructor in remote pilot training organization. So today agenda for the session, that is drone data, elements of image, video interpretation, introduction to photogrammetry, types of image and video, drone video data analysis. So actually we are collecting a lot of data from the drones, because drones, I said, it is used in various industry. That is majorly, that is agriculture industry, videography industry, mapping, surveying. So we send the drone, we fly the drones on the different places, we collect the data by using the drones. So the data, generally there are two types of data, that is process data, measured data. Okay. So measured data, that is the data we are collected from the drones. So because drones, we have the SD cards, like storage devices. So it is actually fitted on the drones. So we fly the drones. It may be agricultural field, or it may be surveillance, land mining, mapping, So we can fly the drones in the different areas. So we collect the photographs, videos. So this data will be stored in the drones, that is memory cards. So that is the data is called measured data. Okay. So once the data is collected from the drones, so what we do, we collect all the data from the drones and we take into the laboratory, that is data processing lab. So in this data processing lab, so we need to process the data. What is the data collected from the field? Okay. So for example, if I'm going to some like a land mining industry. So I go to the mine, I need to capture as much as data possible using the videographic drone or photographic drone, and this data will be processed in the data processing lab. So we have here we use this what I said, artificial intelligence, machine learning algorithms. So it will be identify the data, arrange the data, stitch the data, and it will be organize the data. It will give the output data, resultant data. So how this data will be used? I will give a good example. So for example, we have the videographic drone as well as agricultural drone we are manufacturing. So we generally what type of problem we are facing, we are solving. Like in agriculture field, we send the videographic drone, we take all the agriculture field data. Field data means like a videos, photographs. So we collected all the data from the field and then we process all the data and then we will give the resultant for 1000 agriculture field. So what happened? We have the different type of agriculture field data set in our server. What happened after some time? So maybe 10,000 data it is available in our database. So next future 10,001 data. So there is no need to go to the field. Based on the existing data, we can provide a solution to the new client, new customers. So this is the drone data processing. Okay. So as I explained now, that is the data collected by the drones, and we need to analyze the data. The data may be 2-dimensional data or 3-dimensional data, and we can predict the result based on the machine learning algorithm. So this type of techniques extensively used in different industry, like agriculture industry. As I given one example, that is good example, classical example, that is agriculture industry, mining industry, disaster management, oil and gas pipelining inspection, surveying, mapping, urban planning, military, public safety, telecom. So we can use this type of drone data analysis in most of the industries. So that's why a lot of job opportunity available for this type of drone data analysis, drone pilots. So suppose nowadays for oil and gas pipelining, because in complete India there is oil and gas pipeline is going on project. So if any leakage happens, so what we need to do? We cannot send the manual laborers to go and inspect the leakages in the oils, line, gas lines. So this is troublesome. So instead of that, we need to fly the drones for the complete span length of pipelines, oil and gas pipes, oil lines, gas pipelines. And we need to feed those data into this machine learning algorithm. So there are different softwares also available to predict the result. Okay, so in next slides we will explain how this process works. So these are the field, the drone data analysis used extensively. Next, how this machine learning algorithms works. So it is like a image interpretation. So actually this machine learning algorithm, it interpret the result what we are giving. So what is the input we are giving? We are giving the input as an image or video. So what happened? It will be discretized into small elements. Okay, discretized into small elements, and it will be analyzed. Like what are the different elements? The location, size, shape, shadow, tone, texture, pattern, health, height, depth, sight, association. So these are the different image interpretation elements. So all those elements will be analyzed. So for this, there are some primary elements like color, tone. So these are the primary elements, and size of the elements like this size, shape, texture. So these are the secondary elements, pattern, height, shadow. So these are the tertiary element, and association, sight. So these are the higher order element. So like that, different element will be segregated. So we have different algorithm like we studied supervised learning, unsupervised learning, reinforcement learning. So we have these are the top level classification of the machine learning. So you can go in deep. So they have different type of classification like a long short-term memory, CNN, recurrent neural network, convolution neural network. So there are different type of algorithms works based on this basic classification. So we need to use these algorithms to interpret the what is the input we are getting from the drones. So input may be like an image, like a photography or videography. Like a best example, for example, it is almost like like a kindergarten school, first standard students. How the teacher will teach to the students. So, for example, if they want to explain about the different like fruits, so they will give some questionnaire session to the kids. Like a fruit is like a red color. The teacher will say something. So and then they will ask the kids what is the type of fruit. So kids will say apple because apple is red, and strawberry that is also red, and they will say different fruits, and then they will say the fruit is like a soft in nature. So automatically what happened? Strawberry, it will be left out from the selection. So the apple will be this priority. So this is like a two-level prediction. It is called like a human intelligence because what is the conversation between the teacher and kids? That is human intelligence. Same way, we are trying the algorithm. Okay, there are different type of algorithms. Even I can create some new algorithm. You can also generate the new algorithms, and you can upload in the online platform. So anybody interested, they can download that algorithms. They can use for their data. Okay, so that is the machine learning idea used for image interpretation. So like that, we can plug these two algorithm also. So finally, what we need to do, we need to get the something realistic result. Okay. So these are the different methods. How this prediction, interpretation, like object will be detected, and interpretation, recognition, analysis, classification, detection, idealization, based on the object will be identified. I said, apple example, apple strawberry example. That is the prediction of this is human intelligence. So, but what we are using now, we are using some like an algorithm. So this is artificially we are predicting the what is the fruit. So this is called artificial intelligence. Okay, because artificial intelligence is like a basic platform. So on top of that, we have machine learning algorithm, deep learning algorithm. Okay, these are the advanced artificial intelligence. So what happened? We are predicting the result based on the existing data available. So for this we need to do some testing, and we need to have the test the algorithm, and we need to implement the algorithm. So this is another one of the video interpretation. Previously we seen image interpretation, now video interpretation. So video interpretation it is better than image interpretation because we have this like a speech medium. So that is something better interpretation, better prediction when compared with image interpretation. So it is also have different elements like a tone, shape, size, pattern, texture, shadow, association. So I said different elements for video interpretation, image interpretation. So that is tone, that is color of the object. I said the apple example, and the shape, that is the structure, how the structure will be look like. So what happened? This machine learning algorithm, it is doing one by one verification of the data. That is the thing. Okay, what the kids are doing in the classes, kindergarten or school level, same type of work performed by the different machine learning algorithm. Okay, but we are defining some flow chart. So these are all the things the algorithm should perform. What? First, check the color of the object, check the form of the object, structure of the object, and what is the size of the object, and spatial arrangement. What is the pattern of the objects? How these objects are arranged? Which pattern the objects are arranged? And what is the texture? Okay, arrangement of tonal variation of the object. It is smooth texture or rough texture. And shadow, association, how one object is linked with another object. So for example, if you want to buy the house, if you want to buy some commercial shop, so if you want to buy the house, we need to verify some of the basic features, like what we need to verify. It should be nearby, the house should be nearby the school, playground, some grocery shop or sports field. Okay, suppose if you want to buy some commercial property like a shop, so you need to verify how this property located nearby major transport routes. So like that, we need to define all those information in the algorithms, and algorithm is developed by like a expert people. Okay, so because they need to work on this type of data processing like years together, they will develop the algorithms, and they will be patent, and some people will maybe give for cost, otherwise they sell it to the some other companies. And what we are doing, we are providing all the data to this algorithm. This algorithm, based on this steps provided, it will predict the result, future result. Again, I am saying all this prediction based on how this data, what is the data we are providing. If you are providing realistic, good data, so it will predict the exact result. If you are giving some like rubbish data, so what is the result we are getting? That is not accurate result. So that's why we need to give the data, that is called a training data set. So we need to train the algorithm. First we need to train the algorithm. Okay, then we need to do the testing of algorithm. Okay, so generally we have training the algorithm and testing the algorithm. If you are not training the algorithm properly, what is the output we are getting from the algorithm? It is not accurate, it is not correct. And I said, drones are aerospace field, like a vertical takeoff drones and multi-rotorcraft drones, all uses photogrammetry techniques for taking the image or videography or photography. So the technique used in this is a triangulation technique. So triangulation is nothing but, so it is like a, you need to discretize into small elements. We need to discretize into big images, big photography, big videography into small elements. So what we need to do? So as previously we use different type of camera to take the photos. So instead of cameras, now what we are doing with the drones, we are fitting the camera. Okay, and then we have the tripod to give the static moment to the camera, computers, softwares. So all those things, it is mounted on the drones. The drone may be, it may be vertical takeoff drones or horizontal takeoff drones. Okay, and we need to fly the drones on the field. We need to collect the data in the different field. The field may be architecture building or engineering application, a manufacturing company, or quality control department, topography mapping, police investigation, cultural heritage, geology. So we can use all this photography drone in most of the industrial domain. Okay. So how this videography drones used in police investigation? Because many places some illicit liquor. So what happened? Police, we are getting a project from the police department to fly the drones in the different forest area to find where is the illicit liquor. Okay, so we collect all the data from the different forest area. So based on this data, we can predict what is the places possibility of illicit liquor, and then we can inform to this police department. So this is the one of the project we are working on that. And photogrammetric measurement. So it is almost like like a engineering drawing. We have enlarged scale drawing, reduced scale drawing. Same way, photogrammetric scale, we can scale up, scale down the drawings. So how this happen? It is the distance between the 2 points on the photo. Okay, what is the distance between the 2 points on the photo and actual distance between the real object. So that is called photogrammetric scale. That ratio is called photogrammetric scale. Okay, because sometimes if you read some articles or any photos or images, what happened? They will keep the big building nearby one human being. Why? Because we need to understand what is the scale, what is the reality of the building. So that is called photogrammetric scale. Okay, because photo we don't know what is the scale. It is upscale or downscale photos. So we need to use scaling. That is called photogrammetric scaling. And different method of image processing, like analog image processing, digital image processing. So we have different analysis for video analysis, like artificial intelligence algorithms, facial recognition algorithm. So as I explained earlier, drones used for collecting the data, and so this is the best flowchart how the drones are used for collecting the data and predicting the result and providing the output. Look at these pictures. So the drone collects the data from the construction industry, public administration industry, transportation industry, energy industry, insurance, agriculture. So the flying drone, photographic drone, it is flying on the different grounds, collecting the data, and this data is processed in the data processing lab. Okay, and that is data processing lab, nothing but all the computers installed with machine learning algorithm, deep learning algorithm. Okay. and the result data, the output will be given to the different company. And I said even there are different type of commercial software available for drone data analysis, like Pix4D. That is one of the famous software that is for used for buildings, roads, vegetation, and another one is software that is Westpac Group that is based on Australia. That is called the name is called Shark Spotter. It is to detect the number of shark in the pond. And another one software is called NetLab software. So it is based in the wind turbine blade inspection. And EBB technologies, so that is for property analysis data. And SkyCatch, that is also another good software for material delivery for different construction site. And Arduino, that is another image processing to detect the anomaly in the wind turbine blade inspection. Okay. So likewise, different softwares available for drone data processing. But main thing is that drone data collection is very important. So we need to collect the data from the field. After that, we need to process the data by using some commercial software. Otherwise, there are some people, they are also developing their own machine learning algorithm, deep learning algorithm to predict the result. Suppose I collect the data of about 1,000 from one agricultural field. I can train my algorithm because I have different algorithms. I can train the algorithm with some 800 to 900 data. After training the algorithm, we need to test the algorithm and then we need to compare with the different performance metrics. Okay, what is the error? So then only we can give this report to the client. Then only what is the result we are getting, that is something reliable data. Okay, so this is about the overall idea about artificial intelligence, machine learning in the unmanned aerial vehicles, that is a drone industry. So for collecting the data, we can use like a drone, that is one of the videographic drone, and okay, and agricultural drone. We can use the agricultural drone to spray the different pesticide nutrient. Okay, any doubt on this?
Yes, sir. Dr. Ramesh Kumar, sir.
Yeah, tell me, sir.
Yes, sir. Thank you for the session, sir.
Okay, thank you, sir.
Yeah, the session was really very informative and detailed in the applications of UAVs. Now I request Dr. P. Chandramohan, sir, moderator of this particular webinar, to give the concluding remarks.
Thank you so much. Now almost we have come to the end of today's webinar. We had a wonderful time for the past 1.5 hours to us with the informations more about AI and ML in aviation industry. We started our first session with Dr. Shantakumar Mohan from IIT Palaka, and he briefed or he threw light on various areas related to the aerospace application, particularly AI and ML in aerospace application. He started with giving informations about the robotics, underwater robotics. Then he touched upon the application of aerial robo in HT cable checking. And he also discussed something about the safety and service, enhancement of safety and service using AI and ML in aircraft industry. And finally, he also gave some informations about the risks in AI in the aviation industry. So this is how these are the topics we got to know from informations we got to know from Dr. Shantakumar. And some of the questions were also posted in the question and answer chat box, answered subsequently answered by Dr. Shantakumar as well. I think this is from ICFAI University, Tripura. Some have asked about the motor and motor driver utilization, and about the maintaining of speed and torque in the car. So I think Dr. Shantakumar has answered for their query. And the second session is about handled by Dr. Vasant Kumar, is more about the research and development in this AI and ML in aerospace industry. Here in this, he threw light on ML in aerodynamics and fluid dynamics. He also discussed about the turbulent models, predictive maintenance, unmanned air traffic management, and digital twin. Particularly in this topic, Dr. Vasant Kumar gave information about the ongoing research and the research which is likely to happen in near future in this AAML in aerospace research development. So with the various equations, basic equations, he touched upon this. I mean, he discussed about this topic, and this was quite interesting, I think, to the students as well as research community. And then followed with that, the third session handled by Dr. Ramesh Kumar is more practical. Since he's from industry, he briefed about the drone data analytics in oil and gas pipelines using ML algorithms. He also discussed about various algorithms and basic equipments for creating the 3D models using photogrammetric and related measurements also we discussed in this topic. This topic gave some practical equipment utilization in this field. So altogether, we can say that we have covered the applications, research, and practical usage of these equipments in AI and ML in aerospace industry. So I think we had a fruitful session for about 2 hours, and a few questions were also raised and answered by the resource persons. Now, at this juncture, I would like to thank Dr. J. Krishnamurthy, the chairman of IE Coimbatore local chapter, and Dr. G. Madan Mohan, Honorary Secretary, IE Coimbatore local chapter, for giving us an opportunity to have this wonderful program. I also thank our management, director principal for institution for giving us an opportunity, our team members, all the Department of Aeronautical Engineering team members for making necessary arrangements. The panel members, I would like to thank the one of panel member, the technical executive, Mr. Ayan Dev, for making the necessary arrangements within a very short span of time. Thank you, one and all.
Yes, sir. As you said, the sessions were really very much fruitful and very much informative also. Now I request Dr. G. Madan Mohan, Honorary Secretary of the Institution of Engineers India, Coimbatore local center, to present vote of thanks. Sir, kindly take this.
Am I audible?
Yes, sir.
Yes, sir.
Thank you. Good afternoon, one and all present here. It gives me immense pleasure in proposing the formal vote of thanks in this technical webinar on role of artificial intelligence and machine learning in aerospace. This is conducted under the aegis of Aerospace Engineering Division Board, organized by Institution of Engineers India, Coimbatore Local Center, in association with Department of Aeronautical Engineering, Sri Ramakrishna College of Engineering, College, Coimbatore. Foremost of all, I extend my sincere gratitude to the President of IEI, Chairman, Aeronautical Engineering Division Board, Deputy Director Technical, and especially Engineer Ayandeb, Executive Technical, for their unwavering support for conducting all our activities. Thank you, sirs. On behalf of IEA Coimbatore Local Center, I extend my heartfelt gratitude to today's esteemed guest speakers, panelist, Dr. Santakumar Mohan, Professor, Department of Mechanical Engineering, Indian Institute of Technology, Palakkad. Thank you, sir. Dr. G. Vasant Kumar, Assistant Professor, Department of Aerospace Engineering, Jain Deemed University, Bangalore. Thank you, Vasant Kumar. And finally, Dr. K. Ramesh Kumar, Senior Instructor, Garuda Aerospace Private Limited, Chennai. Thank you, Ramesh Kumar, for accepting our invitation to address this program. I sincerely thank the principal and management of Sri Ramakrishna Engineering College, Coimbatore, for continuously interacting with our IEA Coimbatore Local Center and for your dedicated support in arranging all the technical activities. I thank Dr. J. Krishnamurthy, our beloved chairman, IEA Coimbatore Local Center, for his welcome address and guiding all our center's activity. I thank Dr. P. Chandramogan, Professor and Head, Department of Aeronautical Engineering, and Dr. P. Karpusamy, Institutional Coordinator, Sri Ramakrishna Engineering College, for their efforts in organizing this program. I thank the participants of this webinar, IEA Council members, committee members, IEA corporate members, industrial members, faculty and students from Ramakrishna Institute and other institutions for their active participations. I wish the participants a fruitful knowledge sharing day today. On behalf of Institution of Engineers India, Coimbatore Local Center, I once again thank you one and all here. Thank you. Over
Thank
to
you.
Ayandeb, sir. You can take over.
Thank you, sir. Sir, the session was really fantastic. I'm looking forward for more such sessions from the Coimbatore Local Center, sir.
Definitely, we will take it up, sir, with your guidance.
Anytime, anywhere, I'm always there, sir. It was really
Yeah.
fantastic, very knowledge sharing. Even we had 105 participants at a point of time. It is
That's great,
fantastic
sir.
to
That's
have it in
great.
that way. Okay,
That's
sir.
great.
With the permission of the chairman, Coimbatore Local Center, I will end the webinar here, sir.
Yes, sir. Go ahead. Thank you,
Krishnamurthy,
sir.
sir, if you kindly allow. Sir, I'll go ahead, okay?
On behalf
Thank
of him,
you.
I'll do that, sir. Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you so much,
Thank you,
all
sir.
the members, panel members.
Thank you, Chandramohan, sir. Thank you, all the
Thank you, sir.
panelists. Thank you, sir.
Thank you, sir. Okay. Thank you.